I'm making a game about reptiles, and one thing that I really wanted to add was a snake that I could animate procedurally through code. Now, there's one massive function in math that everyone turns to when looking to make anything that looks like a wave: the sine function. If you don't know, the sine function is a function in trigonometry that when plotted on a plane creates a wave pattern. There are 3 adjustments that we can make to this wave: frequency, or how tightly packed the waves are; amplitude, or how high and low the peaks of the waves reach; and, most importantly in our case, phase. Changing the phase of the wave makes it look like it's moving forwards or backwards through space, a movement that looks awfully similar to the slithering motion of a certain reptile. So I set off to make the snake follow a sine wave. My first thought was the obvious one. I had already set up the bones for the snake. Why not just set each of their end positions to a point on the wave? Well, as you can see, this approach has a fundamental problem. It doesn't respect the modeled lengths of each of the bones. As we move the bone ending further from its origin, we also end up creating a diagonal bone. The Pythagorean theorem shows us that this diagonal bone will necessarily be longer than the straight bone that we originally modeled, creating this strange-looking stretching. So while the snake does seem to be in a slithering position, we need to find an approach that keeps the bone lengths the same. This approach? Rotating. If we simply rotate each bone without directly editing the positions of the bone endings, the lengths will remain constant, and the snake won't distort like this. We end up with this super satisfying looking slithering animation.